there is another way to solve this problem, okay? We initially show that we have a 3 components: horizontal force, vertical force, and the force due to the weight of water. What the other option is to just make it, simpler. For the horizontal force and weight of the water, it's going to be the same. We don't need to change anything. But for the vertical force, we can actually say that the vertical force representing the force due to this pressure distribution. Okay, this is same as if we consider the constant pressure or the rectangular shape, make it separate from the increasing pressure, which has a triangle shape. What's the point? It's why we do that, because it makes it, easier to find the location or the center of the pressure for each profile. We don't need to calculate YP anymore, because for the constant pressure, which has a rectangular shape, we know if the center of the pressure is actually at the center, and for the triangle shapes, we just learned in the lecture notes, it's about 2/3 of the h. Okay, so if you want to write down the moment equation, it will be horizontal force, which is the same as the previous one, times xh, we found it, plus fv triangle part times hvt, plus f vertical due to the rectangular shape times hv rectangular, then plus fw times xw, which is equal fa times h2. Xh is easy. We just show it should be about 3 meters because I at the center. This height, we can just say that it's about 1/3 of h2. For the triangle, for the rectangular, it's about half of this length. Again, this is the h2. Half of the h2, and xw, we know it. We just show it's about 2.667 meters, and the h2 is also, the given. How are we going to find T or vertical force for the triangle? It's about half of the rho g h, and what's the h here? Is the h2. Okay, we're talking about the pressure due to this profile times area. The density is 1000, the h is about 6 meters, and the area is 6 times 10. The vertical force due to the triangle profile, it will be about 1765, 800 newtons. The next one, the vertical force due to the rectangular shape, is the constant force. Whatever the P1 is, we just need to times it to the this area. Okay, so it means it's the P1 times area, and the P1 is equal rho g times 6 meters, because that's 0.1, and the pressure here is the 6 meters, times area, which is 6 times 10, and density is about 1000, gravity 9.81, and the final answer is 31,600 newtons. Okay, so we can put it in this formulation. That was the the first method we solved. That's the second method. Okay, the only difference that for the first one, this one was about 12 minus yp, but for the second one, we don't need to actually compute the yp. We can actually use the standard shapes centroid. Okay, and you should get the same answer if you put these values in this formulation.